Greetings for the day. My name is Sanjay. I'm from RMK Engineering College in Tamil Nadu, and our problem statement is AI-based frame interpolation, video generation, and display system for WMS services. So basically, we all know about the Indian Space Research and Organization for their fantastic work in the domain of research and development. They specialize in sending satellites and they collect the data from the satellites and they use it for research and development purposes. So our objective here is to develop a AI-based frame interpolation and video generation system for the Indian Space Research and Organization. So let's get straight to the point. And so here we are able to see the Meteorological Department website of the Indian government. So currently, with the technology we have, what we do is we obtain a set of images from the satellites from WMS service providers such as Bhuvan, Vedas, and similar institutes within the Indian Space Research and Organization. And what we do is we obtain the data and we basically overlap the discretized data of various time frames. So with the current approach we have, there are three things that we are able to observe. Number one, we are able to see if an object has moved from location A to location B, or if an object has disappeared, or if an object has appeared. So these are the three observations that we are able to do. And we would like to go a step ahead and see and represent how exactly these changes happen. That is our objective here. So basically, we're going to be getting images from the satellites and we're going to be interpolating and connecting the bridges, the gap between the discretized images of various time frames. And we intend to join them together like a continuous flow of data, which will be seamless and interactive. So what we do is we use this architecture known as FILM, frame interpolation for large models. Let me demonstrate my application. So we have built a web application known as Shinka Jinzai, also known as Evolving Talent. So I've already registered in this website, so I can straight away log in. And here we go. So this is our website, and I like to show a demo video. Get a frame like this, and then after a couple of interval we get a frame like this. We want to make the data continuous rather than simply overlapping the images with one another. So we use generative AI to represent the seamless change of the data. As you can observe, the cloud just slowly disappeared and all of the changes are happening in a continuous fashion. So this is possible using generative AI. So this film architecture, basically what we do is we upload of two time frames and we make sure to generate a video that explains how the frames are formed. Let's say I get a frame like this and then I get a frame like this. So we are able to generate a video and describe the motion or the movement associated between the frames. We're able to do that with the three. Number one is we form pyramids. Basically, we downscale the images. We make the size of the images smaller and smaller progressively, which looks like a pyramid shape. That's why it's called a pyramid. And in each of these stages, we obtain the features and we ensure to do some mathematics and we're able to apply convolutional neural network and we're able to generate the output video using a fusion at the end. So fusion is basically we combine all the outputs from various processes and we generate it into a video. So let me demonstrate how exactly we're doing this. So this is a temperature map that we have obtained. The initial map layer which you saw was derived from Mapbox API, which is a basic structure framework for representing map data. And what we see here is the data which we generated using our generative AI. This current flow are representing the temperature. And what we are doing here is we are combining two different frames obtained in different time frames of the same location. Let's say I want to represent the change here. What I do is I obtain the frames of different timelines, timestamps, and I use the frame interpolation and I generate this frames. and I make it into a data layer and I'm able to put it over the map layer, which I'm able to represent it seamlessly. We can also move the map. This projection is similar to sitting in the center of the earth and viewing the earth, which means we can also go down and we can also go up. We are basically in the center of the earth and we're observing the earth. And let me go for the humidity. So this is a humidity map. We're able to represent, and we're also able to see the latitude, longitude, and the ocean currents, temperature, and all that, the particular area. So this is the beauty of generative AI. We're able to render high performance graphics with minimal computation requirements. We don't need a supercomputer, and we can do this very beautifully. And we went a step ahead and we have combined the data from various sources and we have made it into a 3D interactive globe model. This globe structure was obtained using the Mapbox API, and we apply the data layer over the map layer obtained from Mapbox API, and the data layer we are able to generate using the generative AI. So we're able to see, let's say I want to look this particular area in Antarctic, I can go zoom in, and I can see how beautifully the wind currents are moving in this area. We're able to do this using the power of generative AI. So hectopascal is basically the pressure in the clouds. We're able to represent that as well, and we're able to detect all sorts of movements between the frames using generative AI. This is by far the most beautiful representation we were able to bring with the computational limitations of our computers. And let's describe how exactly this data is obtained. So there are various phases in how we obtain this data. Number one, we obtain the data from the satellites. So the satellites, we cannot directly fetch the images from the satellites. So what we do is there are satellites and there are WMS service providers within the ISRO. So satellites will send the data to ISRO, and from the ISRO, we send API request calls and we're able to fetch the images in different timestamps. And we process it to our backend generative AI program. And then we generate the video and we send the data to the Mapbox API and we are able to render this. Throughout this entire process, we have to expect a latency of about 7 to 10 minutes, which varies from location to location and depending on the changes that are happening within the frames. Let's say if there are more changes between two frames, the video generation takes a longer time and we have to wait for a longer time. So this is the near real-time rendering that was possible with our current computational capacity. And in the future, we would like to make all of these maps into a single menu, and we'll also include various layers for representing the most trivial changes such as vegetation, infrastructure, and more. Thank you.